usually steel in the form of bars called rebar. By embedding steel within the concrete, we give the concrete the ability to resist those pulling forces much better. So let's get started on our journey into the world of reinforced concrete. Alright, before we get to the reinforced part, let's talk about concrete itself. Making concrete is a bit like baking a cake, but instead of flour and sugar, we use different ingredients. The main flour in our concrete cake is called cement. When you mix cement with water, a chemical reaction starts, making the concrete harden and become strong. To give it bulk and strength, we add aggregates like sand and gravel. These aggregates fill up space and provide a strong framework within the hardened cement paste. The basic recipe is cement, water, sand and gravel mixed together in a big rotating drum. This fresh concrete can then be poured into molds to give it the shape we want. And that, in a nutshell, is how we make the basic concrete that forms the foundation of so many structures. So we've got our concrete, which is super strong when you squish it, compression. But remember, it's not so great when you try to pull it apart or bend it, tension. For many structures, like the floor of a building or the deck of a bridge, there are forces trying to bend them. This bending creates compression on one side and tension on the other. The concrete can handle the compression, but it needs help with the tension. This is where our hero, rebar, comes into the story. Rebar is short for reinforcing bar, typically made of steel. Steel is incredibly strong in tension. The big idea is to put these steel bars inside the concrete in the places where we expect those tensile forces to show up. These rebar rods usually have ridges on their surface to help grip the concrete tightly once it hardens. This strong bond between the steel and the surrounding concrete is crucial for them to work together as a team. Workers carefully place a cage or a mesh of these steel rebar rods into the formwork before pouring the concrete. When the concrete hardens, you have a composite material reinforced concrete that combines the compressive strength of concrete with the tensile strength of steel. It's a brilliant partnership. Let's dig a little deeper into how this rebar really works its magic. Imagine a simple concrete beam, like one that might support a floor. When you put a load on top of that beam, the beam tries to bend downwards. The top surface of the beam gets squeezed together. That's compression. The concrete is perfectly happy handling this compression, but the bottom surface of the beam gets stretched. That's tension. Without help, cracks would start to form on the bottom and the beam could fail. Now let's add rebar to that beam. We place the steel rebar rods near the bottom surface of the beam, where the tension is going to be greatest. When the load is applied and the beam starts to bend, the concrete on the top still handles the compression